As we begin to talk about symmetry, we are looking at symmetry of functions, and it's going to be one of our tasks is going to be determine the symmetry of a relation from a graph, or determine the symmetry of a function algebraically. And if we just look at the graph, and thinking about the term symmetry, we're thinking symmetric, which means sort of like a mirror image of each other. And that's what we look at when we start talking about an even function. An even function is something that is symmetric to the y-axis. The y-axis forms its line of symmetry. And I will say that I'm not going to be the greatest artist in the world here, but when we look at a parabola, it's not a very good parabola. But when we look at a parabola, we know that the parabola has a vertex, and then it goes, in this case, this one goes up forever, so it's positive. But what we're seeing here is technically it seems to be the same shape on this side of the y-axis as it is on this side of the y-axis. So the y-axis actually splits it right down the middle. It's called the line of symmetry, and it's reflective over that line of symmetry. And in that, when we talk about a function, we know that a function can pass the vertical line test. So if I took a vertical line here and I ran it through my function, I only touch it one time, and that's what that means, is I'm touching it just one time, and that makes that green parabola a function of some sort. Now, if we were to say, well, what does it look like when it's not a function? Well, this parabola right here seems to be going sideways. And if I were to look at the vertical line test, well, it touches it only one time right there, but right here it touches it twice. It touches it right here, touches it right there and right there. So that's why that's not a function. So using that vertical line test to assist us. And so now looking at that, so we see that right there my line of symmetry is that y-axis. And I can show, not all parabolas though are going to be symmetric or an even function, because even functions here, those are reflective or symmetric about the y-axis. So this is an even function. But not all parabolas are even, because I can draw one out here. I can draw this parabola right here. Not the greatest parabola in the world again. And I can look at it and I can say, hey, by Joe, this is also a function because it passes the vertical line test. Great. But it is not symmetric about the y-axis. Its line of symmetry falls right about there. So this point right there is going to be the x value, my line of symmetry. So let's see here, looking at the rest of what we're talking about, an odd function. Now, an odd function is going to be symmetric, not about the y-axis, but about the origin. So a function that looks like, I'm going to do this function, if I were to rotate it about the y-axis, and I rotated it 180 degrees, either right or left, clockwise or counterclockwise, it would end up, this piece right here, and I rotated around the origin, it would end up right back here, 180 degrees. And then if I rotated it another 180 degrees, it would keep coming around and end up right back here. That is what an odd function would look like, because it rotates. It is symmetric not about the y-axis, but about the origin. So if I do some other examples here, a circle is actually going to be even, because it's a sort of a unique item. It appears to be even because it is symmetric about the y-axis, but it also appears to be odd because it is symmetric about the origin. So just looking at that and then looking at algebraically. Well, algebraically, parabolas. What do I know about these 2 points right here? They should have the same y value. They are going to have the same y value. So my y value is just going to be, we'll call that 3. So they both have 3, and then if we call this x value right here is going to be, we'll call it -2. In that case, this would be 2. And then what do I know about the x values? If I put into my function notation, what does that equal? If it's even, if I put my x, which is right here, if I put my x, I put my x value into the function, I get a 3 out. If I put my -x into the function, I get a 3 out. So it looks like f of x and f of -3x are going to give me the same answer. So f of x equals f of -x. So that's what an even function would look like. And now if we look here mathematically, this value right here and this value right here would be intended to be symmetric about the origin. And this value, if I were to call that 1 and -1, and I were to call this -2 and 2, what do I know? Well, this point right here should be 1, 2. And then the other point right here should be -1, -2. And just looking at that, what do I know? I can see here a pattern, and that is, well, on an odd function, my x value is a negative and my y value is a negative, and that creates an odd function. So just sort of looking at these patterns, and they're going to talk about it more in the lesson. And if we go to the next page. All right, our example here says if f of x is an odd function and the graph of the function includes points in quadrant 4, what else do we know that must be true? Well, okay, the whole gambit, right? Let's just look here. If I have this graph, and they haven't really told me anything other than they said I have points that exist in quadrant 4. Great. Bam. There's part of a function in quadrant 4. I just made it up. That's not quadrant 4 though. This is quadrant 4. Remember, it goes 1, 2, 3, 4. Now when I'm looking at that and it says in order for this to be odd, well, we said if it was an odd function, it was symmetric about the origin. So if we just drew an odd function, that means that this would extend off in that direction. So to be an odd function be true, well, hopefully we know that it also includes points in quadrant 2. And that's simply identifying what an even and odd function may look like. And that's just a quick snapshot of even and odd functions. And then I guess if I were to draw an even function on here, I could say, well, that function right there is technically an even function because it is symmetrical about the y-axis. Okay, so there is symmetry in algebra.